Hello everyone. So in this video, we are basically going to study about the living group. So before we proceed forward in this chapter, it is very important that you know the concept of the living group. We should know what kind of species are a good living group. Okay. We should know what kind of molecules are a poor living group. So that's why we are studying this in a separate video. Now, before we proceed forward with the concept of the living group, you should know the meaning of the Lewis base. Okay, so any molecule or any species which can donate electrons to form the covalent bond can be called as a Lewis base, right? So any molecule or any species which can donate electrons so that it can form a covalent bond is called as a Lewis base. Okay, now let us study some of the factors which are influencing the basicity. You might have heard that a particular molecule is a good Lewis base as compared to another molecule. So what are these factors that actually make a particular species a good Lewis base? Right? There are some factors which are influencing the basicity of a particular molecule. There are some factors which will increase the basicity of a particular molecule. There are some factors which actually make a molecule a poor Lewis base. So what are these factors that are influencing the basicity of a particular molecule? Okay, so first factor which is influencing the basicity is the electronegativity. So how does electronegativity influence the basicity of a molecule? Okay, so first let us understand the meaning of electronegativity. So electronegativity of any atom is defined as the ability of that atom to attract the electrons towards itself. So if I say that atom A is having high electronegativity as compared to atom B, then it means that atom A is able to attract electrons more strongly as compared to the atom B. So if any atom is having high electronegativity, then it means that it is able to attract electrons towards itself very strongly. Okay, so this is just a relative comparison between one atom having high electronegativity and another atom having a less electronegativity. Okay, so if atom is electronegative, then it means that it will not be able to share its electrons. So we already know that a good Lewis base is any molecule which can donate electrons very easily. If any particular molecule is a good Lewis base, then it should be able to donate electrons very easily. But if any molecule is having high electronegativity, then it means that it is able to attract electrons more strongly, and hence it will not be able to donate electrons. So if any atom is having high electronegativity, then it means that its basicity would be less. For example, on moving from left to right in a periodic table, from carbon, nitrogen, oxygen, fluorine. So on moving from left to right in the periodic table, you can see that electronegativity is continuously increasing. Electronegativity is continuously increasing. So if electronegativity is increasing, then it means that basicity would decrease. Why basicity would decrease? Because if any atom is having high electronegativity, it will not be able to share its electrons very easily, and hence its basicity will decrease. Now the second factor which is influencing the basicity is the size of the molecule. So on moving from top to bottom of the periodic table, so this is fluorine, chlorine, bromine, iodine. On moving from top to down in the periodic table, we can see that size increases Since the size of the atom increases, basicity would decrease. Now the third factor which is influencing the basicity of the molecule is the resonance. So how does resonance influence the basicity of the molecule? Okay, so whenever you want to understand any factor which is influencing the basicity of an organic molecule, right? If you want to understand any factor which is influencing the basicity, then you should know that any factor which will increase the electron donating ability or which will increase the electron donating ability, that factor will make a particular organic molecule a very strong Lewis base. Okay, so for example, resonance. Okay, so this is a methyl sulfate ion. Okay, so this is the negative charge on oxygen atom. Now this oxygen can be a good Lewis base if this oxygen is able to donate electrons very easily. Okay, this particular molecule can be considered as a very good Lewis base if this oxygen atom can donate electrons very easily to form a covalent bond. But this oxygen is not able to donate its electrons very easily. Why this oxygen is not able to donate electrons very easily? This is because the electrons on the oxygen, okay, the electrons on oxygen are participating in the resonance. Okay, the lone pair of electrons on oxygen are not easily available for donation because the electrons on oxygen are participating in resonance, right? So this is how resonance will take place. Since electrons are not easily available for donation, therefore this molecule cannot be considered as a good Lewis base. Okay, see, whenever we are talking about the basicity, we are comparing, वी आर डूइंग अ कंपैरेटिव स्टडी. ठीक है ना? हम लोग हमेशा एक रेफरेंस को चूज करते हैं. फॉर एग्जांपल, अगर हम मॉलिक्यूल ए और मॉलिक्यूल बी की बेसिसिटी के बारे में डिस्कस करेंगे तो हम लोग सिर्फ इनकी बेसिसिटी को कंपेयर करने वाले हैं. ठीक है, कि मॉलिक्यूल ए की बेसिसिटी मॉलिक्यूल बी से ज्यादा है या नहीं. फॉर एग्जाम्पल, हमने ए, बी, सी, डी, देर आर 4 मॉलिक्यूल्स, तो हम लोग इनकी रिलेटिव बेसिसिटी को कंपेयर करेंगे. फॉर एग्जाम्पल, इन 4 मॉलिक्यूल में से किसकी सबसे ज्यादा बेसिसिटी है. ठीक है, जब भी कंपैरिजन की बात होगी तो देन इट विल बी अ रिलेटिव कंपैरिजन. ठीक है, लेकिन यहाँ पे फॉर एक्सप्लेनेशन पर्पस आई एम सेइंग दैट सिंस यहाँ पे ऑक्सीजन के जो इलेक्ट्रॉन्स है, ऑक्सीजन के ऊपर जो लोन पेयर ऑफ इलेक्ट्रॉन्स है वो यहाँ पे डीलोकलाइज्ड हो रहे हैं. सो दैट्स व्हाई ये इलेक्ट्रॉन्स इजीली अवेलेबल नहीं है फॉर डोनेशन एंड दैट्स व्हाई दिस मॉलिक्यूल कैन नॉट एक्ट एज अ गुड लेविस बेस. ठीक है, याद रखना हमेशा कंपैरिजन रिलेटिव कंपैरिजन होगी. यहाँ पे मैं चीजों को आसान करने के लिए बता रहा हूँ कि ये वाला जो मॉलिक्यूल है दैट कैन नॉट एक्ट एज अ गुड लेविस बेस. ठीक है, बट कंपैरिजन हमेशा रिलेटिव होने वाली है. ठीक है, सो वी हैव डन some of the factors which actually influence the basicity of an organic molecule. So let us move towards the concept of the living group. So before we move on to the concept of the living group, let me make a statement here. A poor base is a good living group. Right? So if you want to decide whether a particular molecule is a good living group or not, then just check the basicity. If a particular molecule is a poor base, then it will be a good living group. So why am I saying that a molecule which is a poor base is a good living group? So what is the reason behind this? So for example, carbon is bonded to X. Now suppose for example there is heterolytic cleavage. This X is electronegative as compared to the carbon. So this electrons will shift on the X and X will be departed. Okay, this X molecule will be departing, it will go away. So now this X molecule is having a negative charge. So here this X molecule is acting as a leaving group. Okay, suppose for example, just imagine that this X molecule is a very strong base, right? फॉर एग्जाम्पल, ठीक है, ऐसा अज्यूम करते हैं कि ये जो एक्स मॉलिक्यूल है वो बहुत ही ज्यादा एक स्ट्रॉन्ग लेविस बेस है, तो क्या होगा? सो इफ इट इज अ वेरी स्ट्रॉन्ग लेविस बेस, देन इट विल नॉट बी स्टेबिलाइज्ड, वो स्टेबिलाइज नहीं होगा, इट विल नॉट बी स्टेबिलाइज्ड एंड बहुत ही ज्यादा रिएक्टिव होगा। अगर वो बहुत ही ज्यादा रिएक्टिव होगा तो वापस ये कार्बन के ऊपर अटैक कर सकता है, ठीक है। तो हमेशा हम लोग को ये बात ध्यान रखनी है कि हमारा जो लिविंग ग्रुप होता है ना, वो इतना ज्यादा रिएक्टिव नहीं होना चाहिए। इट शुड नॉट बी वेरी मच रिएक्टिव, इट शुड बी स्टेबल। एक बार उसने हाइड्रोलिटिक क्लीवेज कर लिया, एक बार वो डिपार्ट हो गया, इट शुड बी स्टेबल। आफ्टर डिपार्टिंग इट शुड बी स्टेबल एंड लेस रिएक्टिव, ठीक है। इसीलिए जो पुअर बेस होता है ना, पुअर बेस इतना ज्यादा स्ट्रांगली रिएक्टिव नहीं होता है, ठीक है। अगर बहुत ही ज्यादा, फॉर एग्जांपल ये जो एक्स जो बेस है ना, एक्स मॉलिक्यूल जो है ना, अगर बहुत ही ज्यादा स्ट्रॉन्ग बेस होगा तो वो बहुत ही ज्यादा रिएक्टिव होगा, ठीक है ना। सो दैट्स व्हाई अ पुअर बेस इज कंसिडर्ड टू बी अ गुड लिविंग ग्रुप, बिकॉज अ पुअर बेस इज नॉट दैट रिएक्टिव एंड आफ्टर डिपार्चर इट विल बी वेरी स्टेबल। सो दैट्स व्हाई जब भी आपको पता लगाना है कि कौन सा मॉलिक्यूल अच्छा लिविंग ग्रुप है या फिर पुअर लिविंग ग्रुप है, आपको अगर रिलेटिव स्टडी करनी है तो आप उसकी बेसिसिटी को कंपेयर कर लो, ठीक है। जो मॉलिक्यूल पुअर बेस होगा वो मॉलिक्यूल ज्यादा अच्छा लिविंग ग्रुप होगा, ठीक है। सो नाउ हम लोगों ने देखा था कि किस तरह से इलेक्ट्रोनेगेटिविटी बेसिसिटी को अफेक्ट करता है, ठीक है ना। अभी हम लोग लिविंग ग्रुप एबिलिटी के बारे में स्टडी करेंगे। सो हियर आई एम राइटिंग सम एग्जांपल्स, ठीक है। यहाँ पे कार्बन के ऊपर नेगेटिव चार्ज है, हियर नेगेटिव चार्ज इज ऑन द कार्बन, हियर नेगेटिव चार्ज इज ऑन नाइट्रोजन, हियर नेगेटिव चार्ज इज ऑन ऑक्सीजन एंड हियर दिस इज द फ्लोराइड एनायन, ठीक है। ओके, सो हम सबको पता है कि हम जब लेफ्ट से राइट जाते हैं ना, जब हम लोग लेफ्ट से राइट जाते हैं तो इलेक्ट्रोनेगेटिविटी इंक्रीज करते हैं, ठीक है ना। इलेक्ट्रोनेगेटिविटी इंक्रीज होती है, अगर इलेक्ट्रोनेगेटिविटी इंक्रीज होती है तो बेसिसिटी डिक्रीज करेगी, अगर बेसिसिटी डिक्रीज हो रही है तो लिविंग ग्रुप एबिलिटी इंक्रीज होगी, लिविंग ग्रुप एबिलिटी विल बी इंक्रीजिंग। ओके, तो अगर हम ये चार मॉलिक्यूल की कंपैरेटिव स्टडी करें तो जो फ्लोराइड एनायन है ना, दैट इज अ गुड लिविंग ग्रुप। लेकिन याद रखना कि ये जो है कंपैरेटिव स्टडी है, out of these four chemical species, fluoride anion is the best living group, right? So this is the comparative study, but in reality fluoride anion is a very poor living group, ठीक है। SN2 रिएक्शन के अंदर या फिर SN1 रिएक्शन के अंदर फ्लोराइड एनायन जो होता है ना, वो बहुत ही ज्यादा पुअर लिविंग ग्रुप होता है। अभी मैंने जो आपको बोला कि फ्लोराइड एनायन इज अ गुड लिविंग ग्रुप, दैट वाज ऑन द बेसिस ऑफ द कंपैरेटिव स्टडी ऑफ दिस फोर केमिकल स्पीशीज, ठीक है। Otherwise, fluoride anion is a very poor living group. Okay. Okay. So this is about the first factor influencing the living group ability. Okay. Now we had studied about the how size of an atom influences the basicity. So on moving from top to bottom of the periodic table, size of the atom was increasing, so basicity was decreasing. and hence leaving group ability increases. Leaving group ability increases. Okay, so iodide anion is a good leaving group as compared to the bromide anion, right? Now we had studied about the resonance, how resonance decreases the basicity, how resonance can turn a particular molecule into a poor base, right? So if any molecule is resonance stabilized, for example, this methyl sulfate ion, this methyl sulfate anion is resonance stabilized, and therefore it will act as a poor base. Since it is acting as a poor base, since its electrons are delocalized, the electrons of oxygen are delocalized, and hence this methyl sulfate anion is very stable. Since it is very stable, it will not be very reactive, and hence methyl sulfate anion is acting as a good leaving group. Okay, so these are some of the factors which are influencing the leaving group ability. So this is the end of the lecture. Thank you very much for discussion.